Today's topic is how does a CPU work? Now, this is important to understand because understanding the CPU is honestly the most fundamental step to understanding how computers work. When you know how a CPU operates, you better understand how your program actually runs, how memory is used, and when something unexpected happens with your code, debugging becomes a lot easier. It is the foundation of everything, so let's get started. So, CPU stands for Central Processing Unit. In simple terms, it is the brain of the computer. Think about how brain works. It receives signals, processes them, tells the body what to do. CPU does exactly that with programs. It takes instructions, processes them, directs the rest of the computer's component, and it is not just run in laptops, phones, servers, smartwatches. Literally every computing device has a CPU. So, what's actually inside a CPU? There are five main components. First, the ALU, which stands for Arithmetic Logic Unit. This is what does the actual calculation. Second, the control unit. Think of it like a manager that decide what happens and when. Third, registers. These are tiny ultra-fast storage units inside the CPU itself, and there is one special register called the program counter. It keeps tracks of where the next instruction is in RAM, so the CPU always knows what to execute next in the sequence. Fourth, cache. This is memory that is much faster than RAM and sits very close to the CPU. And fifth, the clock. This works like a timer that sets the speed of the CPU, which is measured in gigahertz. Now, this is the most important part, the fetch, decode, and execute cycle. Basically, the CPU works in a loop, and this loop runs billions of times per second. Step 1, fetch. The CPU uses the program counter to pick the next instruction from RAM. Step 2, decode. The control unit figures out what that instruction is actually saying. Is it an addition? Is it moving some data? Step 3. Execute. The ALU performs the calculation or the data gets moved. And the last step, write back. The result gets stored back into a register and that's it. This loop just keeps running as long as the computer is on. Let's talk about the ALU in a bit more detail. The ALU, Arithmetic Logic Unit, is where all the actual computation happens. It handles four types of operation: arithmetic, addition, subtraction, multiplication, division, logical operations, and, or, not, XOR, basically Boolean logic, comparison, like checking if A is greater than B or if A equals B, and bit shifting, which is essentially a shortcut for fast multiplication or division by powers of 2. Now, how does it work internally? The control unit sends an instruction to the ALU. The ALU takes two input values from registers. Logic gate built from the transistor compute the result. The result goes back into a register and a flags register gets updated. Was the result 0? Did an overflow happen? These flags are used later for condition checks in your code. Let's talk about clock speed and cores. CPU speed is measured in gigahertz. A modern CPU typically runs at 3 to 5 gigahertz. That's 3 to 5 billion cycles per second. Each cycle completes one step of fetch, decode, execute loop. Now cores. One core means one independent processing unit, one full fetch, decode, execute loop. Modern CPUs have multiple cores, 4, 8, 16, even 32. So practically a 4-core CPU can process 4 separate instructions in parallel at the same time. That's why multi-core CPUs feel much faster in real-world use. Now, a very common question: what's the difference between a CPU and a GPU? A CPU has few powerful cores, typically 4 to 32. It is designed for complex branchy logic like if-else condition, function calls, operating system tasks. A GPU, on the other hand, has thousands of much simpler cores. It is best for massive parallel tasks like calculating the color of millions of pixels all at once. A simple analogy: CPU is like a few expert chefs who handle complex dishes one at a time. A GPU is like a thousands of line cooks all matching the same dish simultaneously. That's why AI trainings and graphics rendering use GPUs because it is perfect for parallel workloads. Let's now connect everything together. When you run a program, the OS loads it into a RAM. Then the clock ticks, the cycle begins. Control unit uses the program counter to fetch the first instruction from RAM. That instruction gets decoded, ALU executes it, some math, logic, or data movement happens. The result gets stored in a register, and this entire process repeats over and over millions of times per second for as long as the program is running. Okay, quick recap. 1. The CPU is the brain of the computer. All instructions execute here. 2. There are 5 key components inside a CPU: ALU, control unit, register, cache, and clock. 3. The CPU works in a loop: fetch, decode, and execute. 4. The ALU handles all actual computation, math, logic, comparisons. 5. Clock speed is measured in gigahertz and multiple cores enable parallel processing. 6. CPU handles sequential tasks with few powerful cores. GPU handles parallel tasks with thousands of simple cores. That's it for today's video. If this was helpful, make sure to like the video, subscribe and hit the bell icon for more such content. See you in the next one.